two unknowns, and now we want to go on to working word problems with two unknowns. Now, I've mentioned before that middle school has pushed Algebra 1 down into the middle school, and what I'm going to show you here, I actually learned in 8th grade with sort of a gentle introduction to variables, but it was done in arithmetic setup. These kinds of problems that we have here, if you look at them, I made a box here, and my 8th grade teacher, Mr. Imboden at Princeton Junior High, who had taught my father, who was born in 1919. So when you think that he taught my father like somewhere 1930, and he was an old man then, he was probably born in the 19th century. And he taught math in such a confident way, so I think it was probably the way it had been taught for years. Now, I'm going to go here and just pick a simple problem to begin with. It says, Jane has a collection of nickels and dimes. There are 11 coins in all. The collection is worth 80 cents. Determine the number of each type. Now, I haven't made these numbers really complicated or anything. I'm really trying to teach you how to get organized so that you can solve this sort of problem. And Mr. Imboden made us make a chart like this, and they were labeled number, price, percent, unit value, and TV, which I thought was TV, but really stood for total value. Now, this system was taught to me by Mr. Imboden in 8th grade. It was also repeated, the exact same thing, by my Algebra 1 teacher, Mr. Cosgrove, in Cleveland, near Cleveland, Ohio. So I think this was pretty much the traditional way things were taught. Anyway, this helps you get organized. So we want to find out the number of each type. So I'm going to put an N in here for nickels and a D in here for dimes. And then I put here the price of a nickel. Now you could say 0.05, but then we'd be working with decimals through the whole thing. And both of those math teachers advised me to work in pennies. So the price of a nickel is 5 pennies. The price of a dime is 10 pennies. So the total value, if I have n nickels, the total value is this column times this column. So what goes over here is 5n. What goes over here is 10d. Now it says there are 11 coins in all, so the number of nickels plus the number of dimes is 11, and the price of the collection is worth 80 cents. Now the fact that this is in dollars here, and I have determined that I was going to work my problem in pennies, means that I need to make this be in pennies too. With me? I did put a hint in here in case you needed some help, because you might not have had me to explain that, so I wanted to get it to go away. You could see that on the hint I kept it with the decimals. Who wants to do that? Not me. So my two equations are right here. N plus D equals 11. I should probably put the marker up here. So we're back at our program. And I'll bring the marker up so that I can write on here. Now, so one equation comes from here, and the other equation comes from here. So we have the blackboard down here too, so that we can put in our equations. So let's take the first equation here, n plus d equals 11. Then the other one is 5n plus 10d equals 80. Two equations, two unknowns. I should be able to use substitution, elimination, or whatever to solve them. And since I think the easiest one is elimination, I'm going to multiply this equation by -5, and I'm going to put it down here. -5n minus 5d equals -55. Draw my line, kill off the nickels. 5D, 10 minus 5, 5D equals 5 is 5. I had to borrow one, so it looks like it's 25. I'm going to double check. 5 and 5 is 10. 3 and 5 is 8. Yep. So D must be 5. So the number of dimes must be 5. And since there are 11 coins in all, the number of nickels must be 6. If the arithmetic had gotten really bad, I gave you the equivalent of a calculator over here, but we didn't need to use it, did we? Now we check, and we win. So we have one problem correct. Let's do another problem. Here's another money problem. Gary has a collection of dimes and quarters. So I'm going to use letters that help me remember what they are, D and Q. And there are 27 coins in all. And the collection is worth $4.65. I'm going to stay away from decimals. You can put them in, but if you use them, you have to use them everywhere. And if you don't use them, you have to not use them everywhere, and everything will be all right. So we're going to have, what is the cost of a dime? It's 10 cents, because we got this all in 10 cents. What's the cost of a quarter? 25. So the total value of all the dimes would be 10D. The total value of all the quarters would be 25Q. So we have two equations. The dimes plus the quarters equal 27, and 10D plus 25Q equals 465. Now, I learned these techniques early in my math education, and I found that if I organized my thoughts like this, these what were called mixture problems were not a problem to me ever. So I hope the same is true for you. Okay, I'm going to solve these by elimination, which means I want to get rid of somebody. I can either multiply by -10 or -25, whichever. I'm going to multiply this top one by -10, so I'm going to get -10D minus 10Q equals -270. And then I'm going to add these two equations, and we're going to find out that we get 15 quarters. Number times the number of quarters is equal to, let's subtract that, 5. 9 and 7 is 16. 195, I guess. Let's double check. I'm not so good at it. We could have been using these things over here, but I didn't. 5 and 0 is 5. 9 and 7 is 16. Carry 1, 1 and 2. 1 is 2, and 2 more is 4. So now I want to find out how many quarters, and I could divide 195, but I can think it's going to be 13. But let's just do this over here. 195, and we've got, I'm going to divide by 15, so I'm going to divide them, and I get 13. Let's see. So this was 13. So there are 13 quarters. See how useful it is not to use an X, but to use a Q, so you know what you found when you're done. Now there were 27 coins in all, so there were 27 coins, and 13 of them were quarters. Then that would mean that there are 14 dimes. Hope you followed that. Check, we win. All right, let's look at this one. A candy shop owner wants to mix some candy that sells at $8 a pound and a second kind that costs $11 a pound. He wants to sell 25 pounds of the new mix for $8.60 a pound. How many pounds of each should be combined? So we got the first candy. Let's call that F. Let's call the second candy S. And he wants to make 25 pounds of this candy. And we have to decide, are we doing this problem in pennies, or are we doing this in dollars? And you can do it either way, you would get the same answer. I'm going to use pennies because I don't really like decimals. So the candy that sells, the first candy that's $8 a pound, that would be 800 pennies. And the second one costs 1,100 pennies. and the new mix is going to sell for $860 a pound. So how many pounds of each should be combined? I think I will use my little toolbars over here. This one is going to be 800 F. This one's going to be 1100 S. And this one I'm going to have to multiply 25 times 860. 860 times 25, and I'm pushing multiply, and I get 21,500. Glad I didn't multiply that by hand. So what are my two equations? F plus S is equal to 25. And then 800F plus 1100S equals the 21,500. So I'm going to use elimination again. I think I'll multiply this by this top equation by minus 800. I'll get minus 800F of the first candy. You can see that people do that if they have a certain mix and one kind of candy is cheaper and they say we need to sell this box for a certain amount. Then they change the mixture on the candy that they put inside the box. It's all done by supply and demand. Minus 800 on the second candy equals, and I need to multiply 800. I could probably do that, but I need to multiply 800 by 25. Multiply, and I'll get 2,000. 1, 2, 3, 4. Draw my line and combine these things to kill off the first candy. And we're going to get second 0, 0, 8. 300S is equal to, this is going to drop off, 0, 0, 5. 1,500. I could take this off of this off of this, and we get the second candy. Looks like we need 5 pounds of that. So we need 5 pounds of the second candy, 25 pounds of all in all. We need 20 pounds of the first candy. Check, we win. Hope you followed that. Here's antifreeze. In the olden days, people had to mix their own antifreeze, just like they had to mix medicines. Nurses had to mix medicines, and sometimes doctors and pharmacists still have to do that, I think. So pure antifreeze needs to be added to 7 liters of a 20% solution. So we're going to get 7 liters of a 20%. I'm going to use this 0.20 here to create a new 30% solution. Pure antifreeze is going to be added to 7 liters to create a new 30% solution. How much antifreeze is needed? I'm putting A for antifreeze. Now here's the question that I have to ask you. Use your brain. Pure antifreeze. What percentage of antifreeze is pure antifreeze? It's 100%, so I could say 1. Point. Maybe 1. It's 100%. This is 20%. This is 30%. So we'd get here 0.2 times, I need to multiply that. 0.2 times 7 would be 1.4. I guess I could have avoided. And this is going to be antifreeze. And this is going to be 7 plus A times 30. 0.30 is going to be 2.1 plus 0.3 times A. Just multiplying this. 0.3 times 7 is 21.2. And my two equations are a little strange here. 7 plus a, and I only have one unknown, so I could have put the total amount here, but maybe I should have done that. Why don't we put an F here for the final solution? I went back to doing one unknown. This could have been 0.3 of the final. You can use one unknown like I just did, and it would still get the same result, but let's use two unknowns. So 7 plus a equals the final solution, and then 1.4 plus a equals 0.3 times f, and we can just subtract the second equation from the first, and 7, and we want to say minus 1.4, and we'll add as 5.6. We subtract this go out, and then 1 minus 0.3 minus 0.3 would be 0.7f. I could multiply both sides of the equation by 10, which is what would happen if I had not changed those percentages and got 7f. So we get 8 is the final. So if the 8 is the final, well, how much antifreeze would we have to add, which would have been 1. Check, we win. It's a little strange. I hope that you can get this. This is the nurse adding antifreeze. Oh, we have student and adult tickets. Let's get one of those. Bobby sold tickets to the school play. Student tickets cost $1, and adult tickets cost and this will be the last one, $3. He sold 31 tickets in all. So let's say we have student tickets and adult tickets, and his ticket sales totaled $45. Now, I don't have to go into pennies here because this is dollars, so I might as well use dollars instead of pennies. Now, say he forgot to keep track of how many of each he told, but he knew he sold 31 and he had $45. That would be enough to figure out how many of each he had. S times 1 would be S, 3 would be 3A, and here's the equations. S plus A, students plus adults, is 31. Students plus 3A equals 45. And I think I'll just multiply the top one by -1. So it would be negative S minus A equals what is that? Why did I have 31? Oh, yeah, equals -31. I did, because that was, I got my first equation from the bottom line here. So now we add, we get 2 adult tickets equals 1 from 5 is 4, 14, so there must have been 7 adult tickets. And that means that there must have been 31 minus 7, and we'll push the add button, and we find that we had 24 student tickets. We could put the numbers back in here and check, or we could check here. Hope you followed how to solve word problems when there's 2 unknowns. These are called mixture problems. Sometimes they're put in books, sometimes they are not. Nurses and pharmacists and people dealing with farming and putting fertilizer and things that have different kinds of mixtures, antifreeze, car solutions, they still need to be able to do these problems, but sometimes people think that they're not real world. Well, they're maybe not quite as hard as the real world ones, but they give you a structure on how to approach real world problems. Hope you get so that you can do the word problems with 2 unknowns. You could actually use 1 unknown. You could have put this down as 31 minus S if you had only studied 1 unknown, or you might prefer to do that. If you do that, you can have end up with 1 equation and 1 unknown, or 2 equations and 2 unknowns. Both ways make it solvable. Thanks.